Hi, my name is Talia. I'm a staff member at Discovery, and I'm going to help you do your homework today.
So SpongeBob has 6 coins. He has 3 dimes, 3 quarters, and Patrick is trying to steal some from him. And this question asks you to find the variance of the total amount of money that Patrick could steal from SpongeBob when he takes 2 coins at random. So if you think about it, this number, the total value that he takes from SpongeBob, is a random variable because he can't really control which coins he takes. So we can define our random variable x as total amount Patrick steals he takes 2 coins, and you want to find variance of x. And if you remember earlier from previous problems, a lot of the times we can set up a table for a random variable that defines all of our possible values and the probability of each value occurring. And this makes it a lot easier to then do calculations like this later on. So if our random variable x is a total amount, what are all our possible values? If you think about it, if he takes 2 coins, he can take 2 dimes, right? And so his total value, his total money that he has is 0.2, because you add this twice. Our next possibility is having 1 dime and 1 quarter. That's $0.35, 35 cents. And our last possibility is picking 2 quarters, and that's 0.5. So now we have to find the probabilities of all of these options, all of these different amounts. And we have to do that using the multiplication rule without replacement that we learned in previous chapters, or previous units, whatever. So if you remember correctly, the multiplication rule, it's like for and, he picks like, for example, the first choice, he picks 1 dime and 1 dime. So first time there is 3 dimes out of 6 total coins, so 3/6. The second time he picks a coin, there's only 2 dimes left and 5 total coins left because he picked one out. So it's 3/6 times 2/5. Picking 2 quarters is the exact same because there's 3 quarters and 3 dimes. So 3 out of the 6, and then 2 out of the remaining 5 are still quarters. Here, let me move this down so it's not crowding out. Okay. Okay, and this middle probability, picking 1 dime and 1 quarter, this is a little trickier, and this is, I think, why this problem gets a lot of incorrect answers, because a lot of people's gut instinct is to do this and say, okay, well, there's 3 dimes, picking a dime, and then there's 3 quarters left out of the 5 remaining coins, so 3/5. I pick a dime and a quarter. Now I'm done. But this is wrong. And you can figure that out by, after picking out all these probabilities for the table, if you multiply them and add them all together, your answer is not going to be 1. And that's wrong, because the final, all these probabilities added together needs to be 1, because those are all the possible outcomes that you have. And the reason why it's not 1 is because we're missing a case. And the missing case is attributed to this, because yeah, we can pick 1 dime and 1 quarter, but we can also pick 1 quarter and 1 dime. So you need to do this twice. So you do, so this is 1 dime and 1 quarter, like I said earlier. Now I'm gonna pick a quarter first, okay, 3 out of the 6, and then dime. So 3 out of the 5. And that's your total probability for picking 35 cents total. And now you can evaluate these to be actual numbers and not just a bunch of fractions. I did this earlier, it's 0.2, this is 0.6, and this is 0.2. So now we've set up our random variable, we have all the information we need, and we can start actually solving for the variance. And if you remember from class, the formula for variance is x1 minus the expected value, EV, squared times the probability, P1, which is the probability of x1 happening. And then plus x2 minus EV squared times P2 plus blah, 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 until you get to the end. xn minus EV squared times Pn. But notice to fill out this formula, we need to know the expected value first, and we don't know that yet, so let's calculate it. It's not that hard. All you have to do is x times px plus x times px, or in more formal terms, x1 p1 plus x2 p2 plus blah 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 blah. So filling that out, we can do 0.2 times 0.2 plus 0.35 times 0.6 plus 0.5 times 0.2. And evaluating that, you get 0.35, which actually makes sense if you think about it, because if you look at our distribution here, this is what it looks like, right? Like 0.2, 0.35, 0.5. These have the same lower probability, and this one has a higher probability in the middle. This is our expected value. This is what we're most frequently going to get, and what our data is going to kind of center around. So that just like, you know the answer is right. Just double checking it. And so now that we know this, we can go ahead and plug everything into the variance equation and find our final answer. So you have x1, 0.2 minus EV, which is 0.35, squared times P1, which is 0.2, plus 0.35 minus expected value, squared times probability that you get 0.35, plus 0.5 minus 0.35, squared times 0.2. And it's a lot of numbers, a lot of writing, but you just gotta punch it out into a calculator, and when you do, you will get the final answer of 0.009. Let me double check. Yes, 0.009. And so that's the variance of the amount of total money Patrick will steal from SpongeBob.